All right. Hello, YouTube. I'm Brad, and today we'll be doing Sprint 28 from 12221. It's an elementary school test, and so you think that since this is one of the later problems on the Sprint, the this would be a pretty difficult problem, but we'll see that like with help of a bunch of number tricks, we can actually get through this pretty nicely. So, what's the sum of the digits of the greatest four-digit positive whole number that has these remainders? And so, whenever you see this, right, you just think, there has to be some number, right? It doesn't even have to be the greatest four-digit number, but if you can find some number such that x divided by 7 has remainder 4, x divided by 9 has remainder 5, and x divided by 11 has remainder 6, what you know, right, is that x plus the least common multiple of 7 times 9 times 11 also has these remainders. This just comes from the fact, right, that if you have x plus, let's say, 7 times 7, or any other thing, right, and you divide this by 7, right, this will have the same remainder. So if you add a multiple of 7, 9, and 11, you'll still have the same remainder when divided by 7, 9, and 11. And so we'll go with that. So what's the least common multiple of 7, 9, 11? Well, if you just take a look at the prime factorizations, right? You have 7, 9 is 3 squared, and 11. If you take the greatest power of every single prime you have, that's 3 squared times 7 times 11, which is just 7 times 9 times 11. That's the least common multiple. Uh, and so, yeah, we won't evaluate this just yet, but we know that if we can find some x such that x has these remainders, then adding 3 squared times 7 times 11 will just work for us. All right, then, so now we need to go about finding such an x, right? If we want x to have a remainder of 4 when divided by 7, and x to have a remainder of 5 when divided by 9, and x to have a remainder of 6 when divided by 11, right? Then what do we need to do, right? The easiest way to do this, right, would just be start with x equals 4 and keep adding multiples of 7. For example, 11, then 18, and etc., until you get a remainder of 5 divided by 9. Then once you have that number, you're going to add multiples of 63 until you get a remainder of 6 when divided by 11. But that's not what we're going to do, right? We're going to look at some patterns that we see. So what do we see? We see a remainder of 4 when divided by 9, remainder of 5 when divided by 9, remainder of 6 when divided by 11. And so what does this tell us, right? There seems to be like nothing we can see until we realize that like 4 is oddly close to 1/2 of 7, 5 is close to 1/2 of 9, and 6 is close to 1/2 of 11. Indeed, if we double the number, right, 2x, if we double the number, we also double its remainder, right? So this will basically have a remainder of 8 when divided by 7, right? 2x will also have a remainder of 10, double 5 when divided by 9, and it'll have a remainder of 12 when divided by 11. But like this makes no sense, right? You can't have a remainder greater than the number. So I mean, like we can just subtract 7, right? You'll take away another 7, you'll take away another 9, you'll take away another 11. And so you notice that 2x has a remainder of 1 when divided by 7, 9, and 11, which means our number 2x will be 1 more than a multiple of 7, 9, and 11. So what is an even number that is 1 more than a multiple of 7, 9, and 11? Well, that's just 7 times 9 times 11 plus 1, right? That's an even number that's greater than that. So x is just equal to this over 2 then. Now we get into the nitty-gritty computational details, right? When x plus 7 times 9 times 11 times some number k, like we just want to add as many of these as we can, right? Where x is equal to 7 times 9 times 11 plus 1 all over 2. If we just do this out, right? 7 times 9 is 63. If you know your number sense tricks, 63 times 11, you write down a 6, you write down a 3, and you add the two numbers and put it in the middle. So that's 693 plus 1 over 2. And then if you just do the computation out, that's going to be equal to 347. So we now know that it's of the form 347 plus 7 times 9 times 11 times some integer k. And so we want to add as many of these as we can, but like, you know, adding multiples of 693 is just like, you have to figure out how many you want to add, right? So you can just add like 10, then like add 3 more, but like it's hard to figure out exactly how much you need. So we're going to do kind of like a shortcut, right? Another thing that you might know if you've done a lot of number sense is that 7 times 11 times 13 is equal to 1001. This is just like a general fact. It's really nice because this is really close to 1000, and we're going to use this fact, right? If we do 9 times 7 times 11 times 13, what does this give us? Well, that's just 1001 times 9, 9009. But also notice that right here is our 7 times 9 times 11. So we know 9009 is a perfect multiple of 7 times 9 times 11. So we can do 347 plus 9009. And then maybe we'll add another 693 if we need to, but like, we'll just leave that for now, right? So 9009 plus 347 is just do some simple math. That's 9356. And notice that 693 is approximately 700. So if we add another 700 to this, it'll go over 10,000, which we don't want, right? We want our greatest 4-digit positive whole number. So this then is going to be the greatest positive 4-digit positive whole number that has these remainders. So then this is going to be our answer. Finally, once we have our answer, make sure that we go back, we figure out what we want to answer, right? We want to find the sum of the digits with the greatest 4-digit positive whole number. And so 9 plus 3 plus 5 plus 6, again, use your number sense. Look at these numbers and figure out the patterns. So when you're doing this, 5 plus 6 is 11, and 11 plus 9, we know that, right? That's really easy to compute. That's 20, perfect multiple of 10s, really nice. So 20 plus 3 then is 23. And that's our answer. So basically, what did we do? We basically did a bunch of division and like remainder stuff, right? Where we found a number and like we added multiples of the least common multiple of the divisors, right? Of what we're dividing by. But like, that's just the basic thing of what you're going to do. The way that we made this a lot simpler, that made it like a lot easier to compute, is that we use all our number tricks, right? We use the fact that 7 times 11 times 13 is 1001. We use the fact that all these remainders, when you doubled them, were just a remainder of 1. And so basically the key to doing these questions fast is you want to use the number tricks that you've learned. You want to use everything to speed through them and to make them faster.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.